Recall that in our first design, we were unable to calculate the area of a rectangle correctly because when we passed it a rectangle that was actually a square, it treated the object as if it were a square and set both the sides to the same value. Then we considered the lack of inheritance version, where we created a new class called shape that square and rectangle both derive from. So we broke the is-a relationship between square and rectangle and replaced it with one that said that both a rectangle and a square are a shape. However, in this case, we didn't take it quite far enough because we didn't move the behavior of area into that abstract class, and therefore we weren't able to use it polymorphically, but instead we had this nasty smell here where we have to check the type of each one and then call its particular area method. We can fix both of these problems by applying a little bit of intelligence to our design and simply creating that abstract area method on shape. Now that we have that method, we can implement it via override on both rectangle and square. And then we were able to run those same tests that we saw before. Here we have one where we take a shape from a rectangle and we expect to get back 20. And in this case we do. And then likewise, if we take a list of shapes and we deal with it polymorphically by enumerating through it, our code is much simpler now. There's no if-then logic here at all. We are simply adding up each shape's area, and we're not asking each shape for its height and its width or its side length or whatever by some third-party calculating code. Instead, we just are delegating to that shape and say, calculate your area, let me know what it is. If we run this, we will also see that it's now working. So by applying the refactoring such that we take rectangle and square and break them apart so that square no longer is a rectangle since they are not substitutable for one another, and then moving that behavior into shape such that we can access it polymorphically on each object itself, we're able to get a design that now follows the Liskov substitution principle and also is going to follow the open-close principle because we'll be able to add additional shapes and add them to this collection and not have to touch this code that calculates the area of multiple shapes. So when should you take the time to look for and fix Liskov substitution principle violations? If you notice obvious smells like the one I just showed, either where you're doing if-then checks within a polymorphic enumeration of a collection of types, or where you're inheriting from a type or an interface and not fully implementing it. In either one of those cases, you may want to consider fixing that violation by using a better interface or simply fully implementing it, or refactoring your code such that a different base class is used that does in fact offer substitutability. Otherwise, you can use the same rules as for the open-close principle, which is that if you find yourself having to change the code more than once or two times, then it's time to refactor it such that it satisfies open-close principle and also therefore the Liskov substitution principle.